Today is 23rd.
Yeah.
Is it?
Yeah.
Now, yesterday we wrote a lot of stuff here. And I would like to start with that. Then this trig equation will make more sense to us. There are two things I need us to take away from yesterday. The first is this all students take coffee. Let's use coffee because a lot of people like coffee. Yeah. All are positive here. Sine is positive, tan is positive, cosine is positive. Those are the signs. Okay? The second thing is the conversion from angle greater than 90 to angle less than 90. Here, there is no conversion because it's still within acute. When you come here, it is 180 minus the required angle, of course, with the sine involved. Here, the angle will be more than 180, so we subtract from 180, or we subtract from pi, depending on, whether radian or degree. And here, the angle will be 360 minus theta. That's how we convert. But when solving the equation, it's the reverse. So I need you to listen to that carefully. If the angle is within the first quadrant, it remains theta. Now, if the angle is in the second quadrant, somebody claimed, remember yesterday we did arc sine of 1/2, and we said there are two possibilities, 30 or 150, right? Okay? Now, we know the angle is 30. We want to get the equivalence in the second quadrant. So, picture it this way. Some big angle that we used to know is in the second quadrant, which means we must have used this equation. 180 minus that angle, right? End up giving us theta, or maybe alpha, let's put it this way, alpha. End up giving us alpha. Now this angle is theta. This angle is the required angle. I'm like trying to reverse this process. We did 180 minus that angle, we got alpha. So, and that is this 150 now. No, the 30, is it? Yeah. If you want to convert 150, so for example, 180 minus 150 is 30. So this is what I mean. Okay? The reverse is that we don't know what this is. But we know the result is 30 because it's equivalent to this 30. So if I'm looking for this, I take it here, it's positive. Then this comes back. So basically, it's still the same 180 minus the angle. So for the second quadrant, we still have 180 minus the angle. Now this is the only one that has issue, and I need you to listen also. In the conversion stage that we talked about yesterday, we claim that if you have an angle like 230, and you want to convert it to the acute form, we will do 230 minus 180, then you say 50 degrees, right? So tan of 230 is actually tan 50. Remember? Agreed? Now, let's say we don't know what this is. We know that it is 50 degrees when converted. What was it in this region, in this quadrant? How do we get this? So if you look at it, you make this the subject, it's now 50 plus 180. And you see that? So now it is addition, which means now this is like theta plus 180. Finally, I should write that in black because now I'm going to be referring to the colors. So theta plus 180. Finally, for 360, so let's take 320 for example. The angle was 320. Your conversion says it will be 360 minus 320 to get a 40. Now, if this is now the unknown, right? I have my 40, now this is the unknown. What happens? It comes here, and now it is 360 minus 40. So basically, this will still remain the same. So when converting, you know what it is. Those are the ones in purple. But when using it to reverse and solving the equation, you use the ones in black. The only difference is the third quadrant. The third quadrant you had. Every other region remains the same. If you can remember that, you are good to go. Does that make sense? Now, how do we use this? I'm going to show you. So, if you remember this, the red parts and the black parts, you are good. You don't need to worry about this purple. I only drill the purple because that can help you to see the pattern. So you don't have to like try to memorize so many things. That's the point here. Okay? What do we really need this to do? Trigonometric equation. Before now, in Form 1 and Form 2, you only solve trig equation within 0 and 90. So for all the practice, unless I state otherwise, maybe if the instruction in the question is different, we're going to try to solve the trig equation between 0 and 360, even if the question says from 0 to 180. Let's see what happens in each of these cases, so that it is lesser when you're doing your normal practice or when answering the question. Okay? So for this, we solve for theta or maybe x, okay, from 0 degrees to 360 degrees. In some cases, from 0 to 2 pi, depending on how the question is given. 2 pi is 360. All right? So sine x, no, sine squared x, let's put it this way, equals 1 over 4. I was explaining this to two people yesterday who stayed back and tried to do some stuff. So this is what you do. Please pay attention, because this is squared. Remember, this is actually sine x all squared equals 1 over 4. So that's like having a squared equals 1 over 4. So if I need my a, first of all, we deal with the square. It's going to be plus or minus square root of that. Am I making sense? So now you have two different trig equations. So sine x is 1 over 2, or, I need more space, that's why. Sine x is negative 1 over 2. Can you see? Two different trig equations. So this is how you do it. Please pay attention. Here, you are looking for that angle that gives you positive value. So you are looking for the region where sine is positive. If sine x is plus 1 over 2, it means x can either be in the first quadrant or the second quadrant. Do you agree? So this is what I tell students. X is arc sine, right? 1 over 2. Similarly, x is arc sine 1 over 2. Please pay attention to this part, negative I mean. You only need your calculator inverse trig once for these problems. The rest is your all student take coffee and the equation I wrote in black. If you check in your calculator, this gives 30 degrees. But now you need to convert it to all the other possibilities. So the first is going to be 30 degrees. Because this can also be in the second quadrant, which means x is also 180 minus 30 degrees. This 30 degrees again. First and second. Understood? From these two now, x gives 30 degrees. And just use command, 150 degrees. Does that make sense? For the second part, again, you don't need any calculator again. All you need is the equation. When checking this, please listen carefully. Please listen. When you put in your calculator arc sine of 1 over 2 negative, you only get one value. Can you check? Arc sine of minus half. What do you have? In fact, you have a negative value, of which we have never talked about what happens to negative angles. Right? So, ignore that. This sign only tells you where to look for. So, what you will check in your calculator, if this part was not there, what you check in your calculator is just arc sine of 1 over 2. Just have it in mind that negative means you are converting to this. So if I'm doing this and I don't know anything about it, this is the only question given to me, I check arc sine of positive 1 over 2 and I get 30 degrees. But I do not write down the 30. I convert it immediately. That 30 is my theta. So I write here, x equals that 30 degrees that I got in my calculator plus 180. Or that same 30 again. Can you see that? And you get the two values you need, 210 and 330. So these are the four values that this equation must satisfy. What I want you to do is to check each of these. So you open your calculator, for example, open bracket, sine of that angle, close bracket, squared equals what? And substitute each of these here. 30, 150, 210, 330. Check if you get the 1 over 4 again. For each of them. Did you get that? For each of them, is the equation satisfied? So definitely these are the roots of the equation, right? So there are 4 roots of the equation. And that is because we are dealing with 0 to 2 pi, 0 to 360 degrees. If it was restricted, you make sure you stop where it is restricted to. If the question says between 180 and 360, then you ignore this part. Okay? You only consider the negative, because that's where the sign is negative. So don't do everything. You only focus on the agenda, all right? Now, I started from this small stuff. Then we're going to apply our identity in some other areas. So let me see if I can find some more interesting problems. This is easy. Okay. Tan 4x. Tan 4x equals root 3. This time around between 0 and 2 pi. So we're going to leave this answer in radian. That's what it means. Okay? Now tan is positive. So which quadrant are we considering? Say that again? First and third. So you just do the, now this is your unknown. So we are dealing with 4x equals to arctan 3. Can you see that? Now we are dealing with first and third. In the first quadrant, you write the answer exactly the way it is. In the third quadrant, you had 180. Okay? So our 4x, arctan of this is 60 degrees. If you remember your special angles from yesterday. Okay? And if you have a calculator, you check, you get your 60 degrees. But it says in radian, according to the instruction. This interval was given, so that's how you know your answer should be in radian. So what is 60 degree in radian form? Pi over 3. So you write here pi over 3. Okay? Or 4x is equal to theta plus 180. How do I write that? Pi over 3, that's your theta, yes? Plus what? Plus pi. And the rest is simplified. I divide by 4, this is easy. X is pi over 12. Here I simplify first. I get 4 pi over 3, right? Okay? And now I can do that. So I get x is equal to pi over 12. Or x is equal to pi over 3. Or you can do anyhow you want. As long as you get it simplified.
We don't have to change the range.
Which range?
We have to multiply it
By what?
by 4.
By 4? What do you mean? No, the instruction says x is within this. Oh, I see what you mean. If x is within this, it means 4x is between 0 and 8 pi. Oh my God. So that's the range. So we still need more. Okay? Now 8 pi. Now, how many pi is this? This is already 0. But we still need more. Then we are not done. Then you have to add 2 pi. No, this is tan. So I've not thought of periodic. And now that's a problem. Oh my God. Yeah. Okay, I'll just write it and hopefully people can understand. Otherwise, it's okay if you don't understand it now, we'll go back to it. Now, there's something called periodicity of sine and cosine. We are referring to after how many revolution, when you come back and end up getting the same thing. Okay, think of it as your rotational symmetry. This cross is in this rectangular shape. How many times can you rotate it and get the exact same thing back? You can rotate it twice, remember? When this comes here, and when it comes back to the original position. Okay? So we say it has two rotational symmetry of order 2. Okay? So the same way in sine, if you have your sine graph, it goes this way. And of course it's continuous. It's a continuous curve. It starts from 0 up to here. This is 1. This is -1. This point, for example, when does it come back? It's come back after it goes this way, then here. Now this is pi, which is 180. This is 90, okay? This is 270. This is plus another 90, 360. Plus another 90, 540. So if you look at it, from here to here, you have a gap of 360 degrees. Okay? If you pick this point, from here, when do you get this again after complete? You see, it goes here, it touches here, but that's halfway. Right? Comes back. So the point is, after exactly 360, everything comes back to the way it was. So we say the sine function has periodic of 2 pi or 360 degrees. So check this. Everybody bring out your calculator. Pick any number of your choice. Any number of your choice. And press sine 360 plus that number you put. Then check the result with sine of the number alone and tell me if you get the same thing. Did you get the same thing? But that's not all. See, sine of that number, check it. Then check sine of that number plus 360 times any number again. Now this is number 1, this is number 2. They don't have to be the same. So multiple of 360, let's see. Do you get the same thing or not? Yes? Okay, one more. Change this to minus. Change that to minus. Is it too much? Some people are feeling sleepy already. Did you get the same thing?
Yeah.
So that is the periodic nature of sine. So whether you go on the positive or you go on the negative, it comes back to the original after 2 pi. So we say sine is a periodic function and the period is 2 pi. Okay? You will do that much on physics later, and the idea is for me to extend it to wave equation later. Okay? Alright, but cosine is the same. Y tangent is after every pi. Let's try for tangent. Check tan of any number. Tan of any number of your choice. So let's say the number is x. Then check tan of x plus 90. After you check that, check tan of x plus multiple of 90. So multiple k. Check that. After that, check for minus. It's not the same? Really? Okay, let's see
For every
tan.
pi, isn't that 180?
What?
Oh yeah,
180. For every
Did I say pi?
You said for every
Oh,
pi.
no.
Pi
Pi.
is 180.
Pi. I said pi, I wrote 9. I'm sorry about that. Okay, try now. I mentioned periodic pi, and I don't know why I wrote 90. Sorry.
periodic pi.
I thought I said periodic pi about 90, about tan yesterday, or maybe the day I first mentioned it. So, did you get that? So while this is 260, which is 2 pi, this is pi. Not the pie you eat anyway, so don't try thinking of food. So now, why is this important? Because you will still get the same result when you add or deduct every 2 pi. You have only solved this equation for, okay, so we're going to stop here. This is 4x. So while our x must be from 0 to 2 pi, our 4x solution must be from 0 to 8 pi. Okay? Now 8 pi means when you go over this once, that's 2 pi. That's 4 pi, alright? That's 6 pi, that's 8 pi. But you don't have to think about this going 4 times. All you have to do is keep adding 2 pi, and as long as your answer is within 0 and 8 pi, you are good. Now, what is the denominator here? This is over 12, and this is over 3, right? So, if you want to put this over 12, you're going to get like 96 pi over 12, correct? And over 3, you're going to get what? 24 pi over 3. Do you understand? So, as long as this part is within this, and the other part is within this, all answers are still correct. So, we're going to have to write out all the possibilities. Okay? That was an error. I'm sorry about that. And thanks for bringing that to my attention. So let's start from here again. So before we divide, we have to sort this. Is tangent. Okay, so we know this is for the first 2 conversion. Now I'm going to convert all this by adding pi in each case. So if you add pi to this, this is already one of them, right? So I'm going to continue to add pi to this one, because adding pi to this one is exactly this, okay? Adding 2 pi is like adding pi to this one again, right? You get what I mean? So we're going to continue like that. So let's see how much of this we can get. So we need from 0 to this, okay? Depending on what we can get. From 0 to, actually divided by 3 is what we should focus on. So that's 24. So how do we go about this? So one is 4x equals pi over 3. The other is 4x equals, what is this one? 4 pi over 3, yes? Yes? 4x. We had another pi to that. What do we have?
7 pi.
7 pi over 3. We are not there yet. So there's still a lot of them, right? So what we could actually do is just say plus k pi, where k is some number. So I'm going to write a general solution, sort of. So now because addition of this gives this, so I'm going to forget this one. Okay? So let's say plus some k pi. Do you agree? So we can write out all of them later by substituting different values of k. So this will be pi plus 3k pi divided by 3. You understand? So x now will be pi plus 3k pi divided by 12. Okay? So let's substitute. When k is 1, what do we have? Come on, sit properly. What do you have? 4 pi over 12. Okay, so x, remember x has to be from 0 to 2 pi. Okay? I think this is even easier than trying to get 24 pi over 3. Because once you get the general solution, like this, your target now is to make sure your answer does not go beyond that. Do you understand what I mean? So this is even easier. Again, let's go back to what I mean. I'm not using this now. Now I'm using the periodicity stuff. Okay? So I have 4x, this plus some k pi, based on the experiment we have just done, right? So I combine it, I'm going to have this, and when you divide, you get that. So this is the general solution. So now let's get all this solution within this interval. So now we go back to the range. If x must be from this to this, then we must make sure our answer does not go beyond it. Am I making sense, please? Yeah. Crystal? Okay, great. So we substitute the first one, we get that. So the second is what? When k is equal to 2, what do you have? 7 pi over 12. Right? It's not there yet. We need 2 pi. And 2 pi is like Yeah, of course when it is twice the denominator, whatever the denominator is. But this is pi over 3. I should have written pi over 3. Okay, so the second one now, 7 pi over 12, you can simplify. When k is equal to 3, what do you have? Wait, did you put k is equal to 0?
No.
No.
That's the first one.
So yeah, k is equal to 0 should be there also. When k is equal to 0, what do we have? Pi over 12. Right? That's also a solution. Okay? So this is solution number 2. So x is equal to 4 pi over 12, which is equal to pi over 3. Another solution is x is equal to what? 7 pi over 12. Okay? When k is equal to what next? 3. So what do we have? 10 pi over what? 12. Okay? There's so many. Okay, what's that? 5 pi over 6. Okay. Okay, now
A
this
lot of
is,
solutions.
so I think when you had one more pi, let's say, had one more pi, when k is equal to what? 4. What do we have? 13 pi over 12.
We're not done.
It's gonna take a long time.
No, let's see. Let's see. It has to be an easier way. Otherwise, I'm okay to just leave it this way. Let's add one more. When k is equal to, is it 5 now or 6? 5. What do we have? 15 plus that? 16. Uh-oh.
8
Yeah.
over
I
6.
thought there's only going to be 8 answers.
8?
1, 2, 3, 4, 5.
Yeah. Are we up to 8 already?
So there should only be 8.
No,
We're not at 8.
we're not at 8.
We're
We're
not.
not done.
Okay, wait. So x is equal to 16, right?
Yes.
Over 12, which is what? In simplified form? 8 pi over. Can you just please, what is 4? 4 pi divided by 3. Okay, so this is like 1.3, close to 2. When you had, what is the last number substitute? 5. When you substitute 6, you have 21. That might be the last one. Okay, 21, is it? Because, no.
No, 19.
No,
19. Oh gosh. Okay, 19 pi over 12. Okay, substitute one more. 7.
This one's 21, I think.
22.
22. Okay, that should be it.
That's it.
11 pi over 6. So add one more just to be sure. 8. 24 plus 1, 25. That's more than 2.
Yes.
So do we have 8 altogether? 8 altogether?
Yes.
Yeah.
Trust me, I won't give you this.
Thank you.
So we have 8 possibilities. Okay? 8
We
possibilities.
did a question on periodicity. Do you want to know? I'm
What?
not super, like,
What's your question? Go straight.
could you do another example for periodicity?
No. Forget about periodicity right now. I'm only telling you what happens when multiples of pi or 2 pi is added. Because that is easier to understand this problem. And the reason is because our unknown is not x. Our unknown, according to the question, start with 4x. It's different from the one I did here, which is just 1x. So basically, the range says x is from here to here. That's not the range for 4x. That's the range for x. So we have to really consider what happens to 4x, and that's the reason for all this rubbish. Okay? A lot of rubbish. I know. So there are 8 of them. Oh my god, this is so discouraging. I shouldn't have told this.
Do you want to
Let's keep the focus, please. Let's keep the focus, please. Okay, this should be different. Can somebody try tan? Some of you, the way you are sitting, you're going to get tired and you're not going to respond properly, and I will hate that my class becomes boring because some people are not really taking it seriously. So I need that momentum that we started with. I need that seriousness. Thank you very much. I think this is pi over 6 equals to root 3. Of course, for 0 less than x or less than or equal to 2 pi. Somebody try this, please. Now, this is not 4x. This is just x. So again, you want to look at the range. If x is from 0 to 2 pi, okay, you want to think of x minus pi over 6, right? From 0 to what? No, that's not from 0. That's from negative pi over 6. Oh boy, what did I do again? Okay, can we forget about this for now? It shouldn't be difficult. I want you to try it later, but so as not to be discouraging. So this is the range of conversion. Can you see what I did? If x is from 0 to 2 pi, we are looking at the range, the interval of this. It's going to be like this. Okay, it's just like subtracting minus pi over 6 from everything. So you are now dealing with from this less than the set variable less than, what is this?